Okay, now let's move on to the next question, which is question number 75. Again, the code is same, code D. So the question says the increasing order of reactivity in the following halides for SN1 reaction, right? So we are going to talk about SN1 reaction. So what comes to your mind when you see SN1? SN1, that means unimolecular. One molecule, I mean, it's just that one reactant is going to decide the rate of the reaction, determine the progress of the reaction, right? So if you could see here the nucleophile does not attack. So if the nucleophile does not attack, then what is going to happen? Right, the reaction has to happen over here. That means this Cl will be substituted by nucleophile, so the bond should break. So that is the reason carbocation is formed, right? So this is basically SN1 reaction, and the driving force for SN1 reaction mechanism is basically formation of carbocation. Correct? Now let's try to write down the different carbocations and check the stability, right? So let's see what exactly is the so I'm just going to write it in a reverse manner. So let's start with the option reactant number 3, correct? So this is the reactant number 3. So this is CH2Cl with a benzene ring, C6H4, right? Para substituted, and then you have OCH3 over here, right? And let's move on to the next part. That is option that is number 2, which is basically CH3, CH2, CH2Cl, correct? And then you have this secondary butyl chloride. So this is CH3, CH with a Cl over here, and then you have a CH2 and you have a CH3. So now what's going to happen over here? So let's see, if I already know that this involves a carbocation formation. So let's see what is a carbocation which is generated over here, and what are the electronic effects that are going to operate in all these cases, and is there going to be some pattern in the stability, whether some stability would be increasing, decreasing. That's something which we are going to see here. So you have a double bond over here, and then you have an OCH3 over here, correct? So this Cl would leave, forming CH2 plus. So this, if you remove this, this is basically a benzyl carbocation, right? So this involves conjugation, right? So there is a double bond and a positive charge connected by a single bond. So basically there is a conjugation, as a result of which the operating effects would be resonance effect, right? So it is pulling, it would be pulling the electron, right? So it is plus R effect, correct? So if you could see here, it's pretty much simple. Now this is involving plus R effect as well as inductive effect, right? CH3 is donating the electron, lone pairs are also increasing the electron density. So what exactly is going to happen? So electrons are being constantly supplied to CH2, so the positive charge would decrease. When the positive charge decreases, stability would be increasing, right? So this would be formed. This would be formed in this reaction. So the two effects which are operating over here is resonance effect and inductive effect. Positive inductive effect, which you call it as plus I effect, correct? So let's see the carbocation which is generated over here. So unless there is a rearrangement of this carbocation, what could be the carbocation which could be generated? So this is basically the primary carbocation, which is N-propyl carbocation, right? So this is a primary carbocation, and the stability factor over here, so carbocation, the stability factor is basically, it is stabilized by plus I effect, or plus I effect is operating over here. So if you could see the third one, if Cl leaves with the electron, you would be getting a secondary carbocation, correct? So this would be a secondary carbocation. Now what exactly is going to happen over here? So this is secondary, this is primary carbocation, this is secondary carbocation. This has one plus I group, entire fragment. This has two plus I groups which are surrounding this carbon, which is connected to this particular carbon. So there will be more plus I effect, correct? More plus I effect means the positive charge would be decreased. So this would be more stable than this one, right? We already know that order of stability of carbocation. So I'll write it as stability of carbocation is tertiary, secondary and primary, right? So if given a choice between the third one, this is the third one, basically this is the first one, between the first one and second one, first one would be formed more easily than second one, right? So now if you could see here, the least stable would be this, the highly stable would be this, correct? Two effects operating over here, resonance and inductive effect, increases the stability. That means you could simply say the order, if they are asking for increasing order means it should be something like lowest to highest. So lowest is going to be this, so it could be something like 2, correct, and then you would be having little bit more, which is 1, and the highest would be 3, correct. So what is the reason for 2 greater than 1? The reason is 2 is basically a secondary carbocation and 1 is basically a primary carbocation, right. So this is the reason why this would be least and this would be most and the second would be this one, correct. So let's have a look at whether we have this particular alternative over here. Yes, we have 2, then there is 1, then there is 3. So the correct answer for this particular question is option 1.